In this video, we are going to use a sign chart to determine when this inequality is satisfied. So the inequality is x squared minus 3x minus 4 divided by 1 minus x, and we want that to be greater than 0. The way we do this is we figure out when this function can change signs. And so this function can change signs either when it's 0, which would mean the numerator must be 0, or when it's discontinuous, which would be when the denominator is 0. So if we look at our function, let's do the denominator first. So the denominator is 0 when x equals 1. The numerator is 0. We need to factor our equation. X squared minus 3x minus 4. That's equal to, let's see, I can see it. So x minus 4 times x plus 1. Let's just check. So that's negative 4x plus x is negative 3x. And we multiply those two together and get negative 1. So the numerator is 0. Sorry, negative 4. The numerator is 0 when x equals 4 or when x equals negative 1. So what we do is we draw a number line. And we're going to plot each of these points. So negative 1, 1, and 4 on our number line. And we want to answer the question, what is the sign of f of x in each region? So again, to the left of negative 1, we choose a really large negative number. Really large negative number, the numerator is going to be positive because it's dominated by the leading term, which is x squared. And the denominator is also positive because we're subtracting this really large number. So the function is positive. Between negative 1 and 1, we have to test with one value. The easiest value in this region would be 0. So we'll plug 0 into our function, and we've got the numerator is negative, the denominator is positive, so the function is negative. Between 1 and 4, this is a little bit harder, but we'll choose some value. Let's try 2. So 2 squared is 4. 4 minus 6 minus 4, well, that's negative. And 1 minus 2 is also negative. So a negative over a negative is positive. And then finally, in the region 4 to infinity, we choose a very large number. The numerator is positive, the denominator is negative, and so we end up with a function as negative. Now we are interested in when this function is greater than 0, not equal to 0, so we're not interested in the boundary levels. So this function is going to be satisfied, this inequality is going to be satisfied from negative infinity to negative 1, union 1 to 4. Now for inequality, if we wanted to solve, let's say, x squared minus 3x minus 4 over 1 minus x is bigger than or equal to 0, then we would have negative infinity to negative 1. We're including negative 1 because it's equal to 0 there, union 1 comma 4. We include 4 because it's equal to 0, but we don't include 1 because the function is not defined there. So if this were our inequality, this would be our answer.